Welcome back. In this lecture, we're going to go over the solutions for the image processing assessment. Let's open up the assessment notebook and work through the solutions. All right, here I have the image processing assessment notebook. Now let's work through the solutions. We have some convenience code here for you, so go ahead and run that. We've ran in the imports, and we also have this display image. Now our first task is to open and display the giraffes.jpg image that is located in the data folder. Hopefully by now you're pretty much a pro at opening files, so we'll say cv2 imread, and inside the data folder, we're going to call in giraffes. Whoops, make sure it's actually, I'm spelling it right. Giraffes, there we go. And because I want to display this, I'm going to reassign the color channels. We'll say CV2, CVT color, let's say image, CV2 color, and by default, we have BGR, and we want to convert that to RGB. So if we run that, whoops, CV2 underscore. There we go. Okay, then we'll say PLT, actually we have the display image, so we'll say display image, IMG, run that, and you should see these two giraffes somewhere in the savannah. Okay, the next task was to apply a binary threshold onto the image. First, I'm going to show you what happens if you try to apply the binary threshold onto the raw image, and then I'll show you how you can actually get the results expected in the notebook. Although, depending on how you interpret this, they're technically both correct. So we're going to say ret and thresh1 is equal to cv2, and the command here is just threshold. And then we'll pass in the image. We pass in the midway point, so that's commonly just between 0 and 255, 127, but you can always adjust this. And then the max value is 255. And then we'll say cv2 and call thresh, and in this case we just want a binary threshold. Now if you apply this directly onto this color image, what's going to happen is it's going to apply that binary across the three color channels. So that is technically a binary threshold, so you can display the image and show thresh1, and this is a binary threshold on the image, however it's doing it across all the color channels. So if you actually want to fix that, what you can do is reload the image in grayscale. So you can just come back up here, load this, and in fact we only need this first line. And remember, as a second parameter, you can just say comma 0, run that again, and then you see this in grayscale. And if you actually want the color mapping to be grayscale, you can just provide cmap gray, run that, and then we have the binary threshold on the grayscale image, so everything is either black or white. Okay, so then the next task was to open the giraffes.jpg file from the data folder and convert its color space to HSV and display the image. So you can say image is equal to cv2, image read, and in this case it's in the data folder, it's called giraffes. And if we want to convert to a different color space, all we need to say is image cv2, cv color, pass in the image cv2 dot color underscore, and in this case we're going from blue, green, red to HSV. And then we can display the results of that image, even though they kind of really won't make sense. They'll be kind of a funky looking pair of giraffes. So here we have it now in the HSV space. Okay, the next task was to create a low pass filter with a 4x4 kernel filled with values of 1/10, and then use 2D convolution to blur the giraffe image. So let's go ahead and try that out. We'll start off by creating the kernel as it asks. A couple different ways you could do this, but probably the easiest is to say np1's shape is equal to 4x4, and then we may also need to specify the data type, so we'll say data type is np float32, as we did in the lecture, and in this case we'll divide it by 10. So in the lecture I think we divided by 25. And if we display the kernel, we get back those expected results. Let's now read in the image afresh, so we'll say cv2, imread, and we'll pass in data, and grab the giraffes JPEG, and I'm going to make sure to convert it to the correct color space. We'll say, whoops, cv2 dot cvt color, pass in the image, and then we'll say cv2 color. And in this case, we're going from, again, BGR to RGB. Okay, run that, and then we'll say the result is equal to cv2 filter 2D, and then we'll pass an image. For the desired depth, we can keep the input depth, so we'll say -1, and then we pass in the kernel, and let's display the result. So display image of that result. Go ahead and show that. You can see here, it basically looks a little blurred, it looks a little brighter. Next, we wanted you to create a horizontal Sobel filter, so that's Sobel X, from our lecture of a kernel size of 5 to the grayscale version of the giraffe's image, and then display the resulting gradient. So again, we want to read this in grayscale, so we just need to say image cv2 imread, and we'll say data, giraffes, run that, and then we can say Sobel X for the X gradient, cv2 Sobel, and then we'll say image. For the actual depth, we'll define it as CV64F, just like we did in the lectures. And then we'll say, remember, it's dx that comes first. So we'll say 1 for dx, 0 for dy. And the kernel size, again, this is kind of up to you, but we'll choose 5. And then let's display that image. So displaying those results of Sobel X. And whoops, looks like we forgot to read this in grayscale. Let's try that again, 0. Now we run it. Okay, now it's making a lot more sense. And then we can just say CMAP is equal to gray. Okay, so now we have the Sobel X gradient. Then at the very end, we wanted you to plot the color histograms for red, blue, and green channel of the giraffe image. It's pretty much the exact same code that we did during the actual lecture on color histograms, at least part 1. We'll say image CV2. Let's read in the fresh image. Data, giraffes. I'll set my list of colors. So color, we'll say blue, green, and red. We have it in the OpenCV order, and then we'll say for I, comma, COL, in enumerate color. We'll say the result of the histogram is CV2, and then we just call calc hist. In this case, we pass in the list or an image inside of a list, the channel that we're looking for, which is just the index I from enumerate. We're not using a mask, and then we'll say 256 as that max range value, and we'll define that range there. And then we can go ahead and then plot hist R. Okay, and then we'll say here PLT title, or really whatever you want to call it, my histo. So if you run that, you should see a histogram that looks more or less like this. Keep in mind, your default colors may be slightly different than the ones here. So what we can do is we can say PLT plot, and then set the color to be equal to the color code. So then when you run this, now you get the matching color codes. So red is red, blue is blue, and green is green. Okay, so that's it for this assessment. If you have any questions, feel free to post to the Q&A forums. But keep in mind, you can always reference the solutions notebook, and pretty much all of this was a carbon copy, at least the commands were from the lectures. So if you got stuck on something, definitely review the lectures because essentially all the code came from the previous lectures. Okay, thanks, and we'll see you at the next section of the course.